Welcome everybody. I want to talk about software development. It's not about software at all. First off, who's a software developer in the room? Awesome, just got your hands raised, great. So, it's cold here, so move a little to get warm. If software development is not about software, what is it about? Software development is about providing business solutions or entertainment. But in my case, it's always business solutions. So you're actually helping people to be better at their own jobs. And you need to automate thought processes and business processes for that. And that's why you build software. But software itself is just a means to an end. If you can solve the same problem without software or with less software, you're better off because software is costly to write, to maintain, to read, and to educate. So, who am I? I love developing business software to an unhealthy degree. That's basically all. If you want to know more, we need to drink beer and talk for hours. But I've been doing this for 15 years now, building business software. And I even started my own conference in Berlin because I'm a super big fan of domain-driven design and agile and all those things. And I can't get enough of those topics because I like to excel at what I do. I build business software and I have been really bad at it. I'm still bad at it, but I'm getting better year by year. So, thing is, software is everywhere nowadays. It's not just business software that you use to calculate some money values. Software is in the cars we drive. There will be self-driving cars pretty soon on the streets, but even nowadays, the brake assistance, the speed control, a lot of things in your car are automated. And then the plane you fly, almost nothing happening in the plane is actually steered just manually by the pilot. There are machines guiding everything and assisting every process. And if you are a software developer, you know how you build software. Now you know why you should be afraid if you enter a plane. But then again, they have good testings, obviously, because it's working. The whole infrastructure of our cities is run by software. There's not a single human or a team of humans thinking about everything. It's designed by systems and maintained by systems that are built by programmers. And nowadays, we even let software into our home and talk to it every day. I mean, who here really gets up and touches a button to turn the light on, right? So you say, okay, system of your choice, do stuff for me, make my coffee, turn the heat up, and this is getting more and more by the day. Small businesses are run by software. Everything from planning to calculating to sometimes even with artificial intelligence actually predicting what the customers want is run with software. And then the systems that connect all of us on a global scale. And now we're even getting to Mars and bringing Wi-Fi over there. Elon Musk is doing it in his lifetime. So software is actually everywhere and is controlling or integrating into every part of our life. But the problem is that software becomes what the developers understood, not what the business people meant in the end. So it doesn't matter how well written your documentation of 300 pages is, if I as a developer am not keen enough to read 300 pages or don't get a way of asking you for what you actually meant, it will be really hard for me to provide the actual value that you want to have. So there are 3 key abilities you need to actually build good systems. Who want to guess? What's a great key ability you need to build a system, to build good software? Oh, great, empathy, yeah. Another one? Being interested, of course. So, communication skill, thank you very much. Now we have all 3. So it's communication, empathy, and the ability to learn. You need to be able to communicate to people, to your own business partners, to your own programmers, but also to your customers. If you can't communicate well, you cannot describe what you want, or you cannot really understand what other people want. If you don't have empathy, you never realize if they're telling you the truth. You know, a software developer that says, I get it, let's do that, or I get it, let's do that. Completely different message, but you have to have the feelings for that. And then the ability to learn, not only about code, not only about the technology to use, but also about the business problem itself. You need to become an expert in whatever business you're trying to help with your software. So, you should organize your structure of the company around the business needs. If you build your company as a development company and you have your database team and your business logic team, your analyst team, your design team, you're prone to fail. Unless you're building software for databases or UI development or stuff like that. But if you solve business problems, you should structure your company around the business needs. There's a nice saying by Melvin Conway, said organizations which design systems are constrained to produce designs which are copies of the communication structures of the organizations. So if you work with a team and people in that team really don't like you and you know that, so you always have to defend yourself, or you're getting someone in between that does the communication for you, you will not share a common code base or a common model because those people mess up your code all the time because they are very eager to succeed and they don't care about your feelings. So whatever the real communication structure is also the structure that you will find in technology later on. I'm defending my code base from your code base, from your influence, when we don't like each other. If we both work together every day, we will share a common code base, of course. So we can both excel together. So discovering bounded context. A bounded context is exactly that. It's a topical boundary, a language boundary around a certain part of my business. Let's say we want to build a great online shop, Beamazon. And Beamazon, as a second competitor, we have shopping and payment and delivery and warehousing and also other contexts, but I don't want to build a system that is all one big system, one big ball of model and code, where if I want to change something in shopping, I need the payment people to test their system afterwards, right? I want to be able to say, look, if something in shopping algorithms change, if our model changes, I want to be able to do that without having to talk to everybody in the company and without having to test if everything else is still working. I want to have clear boundaries. But then again, if I find very small bounded context, it makes it very easy to build one model and one code base, but it makes it really hard to integrate the whole system because distributed systems, microservice architecture, whatever, it gets complicated to orchestrate everything. But if you build it to big bounded context, then you have too many different topics in one part of your system. So you need to find a good middle ground, and how to do that is what half of this talk will be about. So different bounded contexts have different complexity. Who's heard of the Cynefin framework? Awesome, that gets more and more every year, like that. So there are different kinds of complexity. You have obvious complexity. For me as a German, I sense the beer's empty. I categorize it, that's a lethal problem. So I respond. I delegate you to get a crate, put it in there, let's drink again. Problem solved. In obvious problem complexities, you can do best practices. You can sense something, categorize, and then you can delegate as a response. Hi, we see you anyway. So there's obvious complexity, and you can solve it with a best practice that you can just read or remember. In complicated scenarios, I'm driving a car on the highway and the car breaks down while I'm driving, like, oh my God, what do I do? There's no best practice now. There are good practices, but you have to study or need experience or need a team of people who can actually think about this and solve this. So in complicated scenarios, you need expertise. And then there are complex scenarios. In complex scenarios, the best answer is impossible to derive in the beginning. No matter how smart you are, no matter what you studied, and no matter how many people you bring in, you can't fix complex problems by finding a good solution. You need to sense something, and then you need to do a scientific method, probe it. I have a theory, if we try this, that just might work. Let's experiment with this. Then see what happened, and then experiment again. More and more and more, iterate over the complexity until it becomes only a complicated problem for us at some point. So for example, the whole taxation system in Europe, you have taxes, local and Europe-wide. You have companies and their financial politics, and the whole thing is so easy to solve. If only every country would say, let's do 25% of taxes for everyone, that would solve everything, right? You don't know that. Whatever great idea you had, whatever you talked about in the bar while you were drinking the refilled beer, you have an idea, and if you change something, people will change their behavior. Companies will move away or move in. Other countries will protect themselves or not. There's so many different complex players at hand, you can't predict what's happening. So you need to find ways to probe it and do local controlled experiments to gather insights. And then there's chaotic environments. Environments where you don't even know what the problem is or where the problem changes every day. That's a high risk area, but it's also an area of innovation. So in a chaotic environment, what you can do is you act. You don't know what's happening here. You can't even make a nice probe or a nice hypothesis. You just act, and then you look what's happened, and then you respond, and maybe you repeat or maybe you leave. So if you have these different kinds of complexity, you need to find the ways to structure your bounded context around these complexities. If you have, for example, as we said here, as we said in the shopping context, shopping is very complicated, so we need experts who know psychology and who know how market works. A warehouse is just an obvious problem when you solve it. But then again, maybe it's complicated. That's why Amazon is putting a lot of automation in there. So finding what kind of complexity is in my bounded context helps the team that is working on that bounded context a lot to understand in which way they should work. Probing scientifically, or just getting smart people, or just delegating something to people who can do the work for you. So we need to find the boundaries that enable us to deliver and optimize our core domain. In Beamazon's case, what's a core domain? We have 4 different. What is a core domain here? Shopping, right. So, shopping is a core domain because that's what we do, that's what we excel at, that is what makes us different than our competitors. We have better shopping methods. We can give you better products to buy, and we can show you recommendations what other people bought, so you're really inclined to click and buy. If we get better at payment, that's not really our core business. We can give you the best payment system in the world, but if the products are crap or the recommendations are crap, you'll not buy anything. So shopping is our core domain for now. Maybe if we go Amazon's way, it was core domain at one point, and then after a while, warehousing became the core domain, and now selling stuff is just a hobby of them, and what they actually do is cloud services. But our core domain is shopping, and then we have a supporting domain, that's warehousing. Core domain means this is the essence of our business, and supporting domain means this is still specific. We need to build it ourselves. We can't buy it off the shelf, but it's not the essence of what we do. So this could be done with a little less effort. It doesn't have to be that perfect. You know, if we do all the effort in all the parts of the whole system, we'll never finish. So we try to build the best part that we can in shopping, but the supporting domain just needs to work well enough so the system as a whole works. So in that case, payment is a generic solution. That means payment is a problem that all companies have. And it's so generic you can buy it off the shelf. If Amazon does payment by PayPal, we can also do payment by PayPal. We don't have to build our own payment solution. Because credit cards, PayPal, and all the other things, it's already a solved problem, and it's very generic. Categorizing your problem domains into generic, supporting, and core gives you a lot of strategical benefit to actually think about where do I put the smartest people, where do I put the most effort in, and where do all my resources go to. And then payment, you can even decide, build it or buy it, whatever you want. So in this case, we know shopping as a core domain is upstream and warehouse is downstream. Upstream means if I put dump into the river upstream, people downstream will get all the dump in their face, but people who swim upstream, they don't care. So the upstream model is influencing the downstream model, and decisions in the upstream team are influencing the downstream team. That means as a strategical map, we now know if you work in shopping, you will influence the business way more. And if you want to change your model to improve your core business, warehouse people have to adapt at some point. If warehouse people say, we want to change our model and the way we work, they need to negotiate. And sometimes they have leverage, sometimes they don't. But if you make this a transparent map, if you communicate this idea very well, you will not get so much disappointment. If I don't know my strategical position in my company, I'm just annoyed by the team that is always doing stuff that I don't like. And I try to defend myself or get aggressive or fight back. But if I understand, oh yeah, for strategical purposes we're the downstream team because that's a supporting domain, then I understand. If I want to change the company, I want to work in that business part, but making these things transparent is very good for a healthy communication culture in your company. And if you think at some point, oh look, they change so often or in ways that we don't like, you can protect yourself by building an anti-corruption layer that is either a piece of messaging software in between so that it's actually doing translations. Whatever they change, you don't have to care because the anti-corruption layer will do the translation, but it's also a social thing. Everything we're saying here is socio and technical at the same time. It could be a person doing the translation or doing the communication between teams, as well as software components between different bounded contexts. And of course we have the delivery context, which is in pair with shopping, because if you buy something, delivery has to work fast. So they have a pair relationship. Whenever they change, they need to change at the same time. They only succeed together or fail together. That being said, delivery doesn't have to be core domain anyway. It can be a supporting domain still, but you have to make it transparent that they both either succeed or fail together. So how do we derive our bounded contexts? How do we see where is the context boundary? It's not always obvious. It's not always shopping and warehouse. If you have different businesses, where do you draw these lines? And there's no simple rule. It's an iterative process, but it's guided by feedback from vision, product, expert location, bottlenecks in the whole process, data cohesion, so things that change together belong together, domain rules that change, and even the code. So if you already have a legacy code base and that's all one big ball of mud, that is your one bounded context you have at the moment. You can draw a target map where you want to be in 2 years and then try to get there, but at the moment that whole thing is one big ball and you have to work with that bounded context. So One important thing is you need one team per bounded context. Well, maximum one team per bounded context. One single team, of course, can have multiple contexts working in. I can say today I'm working in shopping cart, and tomorrow we'll work for a day in payment, and then I go back to shopping cart. That's no problem. But if I am, or if we are the shopping team, they can't be the shopping team also, because we make decisions about the code, the model, what the behavior should be. If they do the same, we either are one team or we have a problem. So you can only have one team per bounded context, and that team includes technical people and business people, here shown with yellow and blue. So the business people have documentation, ideas, and specifications, and the technical people write the code and talk about the implementation details, but they need to understand each other because we build software together. But then there's a problem. If you have a team of people that works together, they need to be able to communicate, because it's about communication, empathy, and the ability to learn, right? So if communication between people drops off, communication between people drops off radically as soon as the distance between each other exceeds the length of a school bus. For the non-Americans, that's roughly about 10 meters, maybe 12. So if I'm sitting in an office and there's a next room, I can hear people talking. I can hear them argue, or I can hear them happy. 3 rooms further down the floor, I can maybe still get something, and we meet each other in the coffee break, but in another building, I don't hear anything from them. I see what they write on Slack or what they write in other communication digitally, but the non-verbal communication is so much more important. So when I'm in the room and I'm shipping stuff, yes, good update. And then I hear the other team in the next room saying, "What the Marco?" And then the next thing I see is a Slack message, "Marco, can we please talk about this commit of you?" You know, I have meta information that is very important. So the whole empathy thing only works if you see and hear people. There's so much in nonverbal communication. Way more than 50 or 60% of every information you convey is nonverbally or paraverbally. The way I intonate my voice, the way I stand while I talk to you. All these things have meaning, and you only see that if you actually see or hear people. So that means, is remote working impossible? No, it's not impossible, but you need to be aware of the problem. So the moment you have a remote working team, this needs to be transparent for everybody, that you need to put extra effort to communicate well. It's not the same to say something or to write something, and you need to be aware of that. And that leads me to emotional safety. Google did a study a few years ago about the most successful teams, and I kind of gave it away, but what do you think is the thing that the most successful teams had in common? Just taking the break to drink. Yes, it's emotional safety. So it wasn't expertise, it wasn't people who studied math, or it wasn't an age difference or a gender gap or whatever. It was emotional safety. Those teams who felt like, oh, these are my buddies, we can really trust each other, we have deep trust. Not only I'm not trusting that you do the job, I trust you with my vulnerability. I can say, look, I made a mistake, but what can we learn from this? And I know you will not abuse that, my openness. You'll cherish it. You say, oh, great, yeah, let's learn from there. Let's move together forward. Teams who had emotional safety excelled the most. If you have mediocre people, like with a mediocre talent, but they are an emotional safe team with deep trust, they excelled and exceeded teams made of rock stars who all thought, I'm the best. So, if you don't have emotional safety, 2 things happen frequently. You get silence and violence. Some people withdraw themselves. They just say, well, no, I don't care. They never put up with the effort. They don't bring in ideas. They withdraw themselves from the work. They just do what's necessary. They avoid taking on risks so they don't get punished for that. And they mask themselves behind the work of others. We as a team did this. Great. I did nothing, but who cares? Yeah, so you get silence, and on the violent part, you get people who, if they feel insecure or if they just get the chance because they're psychopaths sometimes, you get people who control others. You know, you, why don't you just do this? I can do this every day, and at some point you just give in because you are on the other side and you don't want to fight every day. But I have the energy, so I'm going to push you. Labeling, you know, that guy is a database guy, so why don't you just fix a database? It's even a great thing. It's not a, you know, you're the database guy, cool. You're the DDD, cool. Awesome, let's do that. So I label people, and after 3 days, they accept that label. Yeah, you know, I'm the database guy, so I'm going to do this. But at some point, you're just the database guy, and I will not hear you when I talk about the other things. And then even there's open attacking. If you're in that environment where people actually attack you, say, what did you do again, Norwegian bastard with your code base? So if you have open aggressiveness, that's a clear sign that you have a big problem. So you want emotional safety, and if you see any of these symptoms, That's something to be worried about and to start talking. You need good communication. You need to be able to speak the same language. And it's not only the same language like English or Norwegian or German. It's not only the business language that you need to speak, or C# for that matter. You need to speak the same emotional language. You need to be able to talk to people and say, look, let's meet, let's have a retrospective. If you do Agile, that's kind of like what you do in the retrospectives. And you need to come together to actually find this common ground where you stop fighting each other and think about the problem that you're trying to solve. Speaking about common language, one big problem is developers are these nerds, right? They look at code. You put pizza under the door and they bring out the best programs in the world. They are hackers at night and they only see, I don't see the colors anymore, I just see guns and matrix and whatever. And then you have business people, and business people, they only see hard numbers, right? And they have the KPI problem, whatever. And these languages don't mix. There's no mapping in between. So business people talk down to developers because they just produce a software and they look at the code and say, oh, this rule changes, now holidays don't count at this anymore. Okay, but my code says something about function of X is lambda, SQL. That's not a good mix. There's not the same language. And that leads to a lot of expectations that are not met, which is one of the core problems of growing mistrust. So if I don't understand what you're saying, I have a problem. What would be the shortest mapping possible between the language of the business people and the code? Yes, 0. Reusing the business language in the code. If we speak the exact same language, if I don't write X, Y, Z, SQL and Hibernate, Docker this, boom, but if I talk your language, even in my code, then we speak the same language and I understand you. So you can ask, why shouldn't just the business people learn programming? Because that's just a means to an end, as we already figured. The business problem is a real problem, and we are the experts who can solve that with our tools. We have the tools of programming. They don't understand that. They don't need to. We want them to describe the problem properly in the right language. So I brought you a good ubiquitous language here. Who has written code like that? Who's lying? Great. So that's default object-oriented programming, and it's really crappy because we have all these weasel words, living space, separation, decorator. Decorator is a pattern. So a weasel word comes from Shakespeare. A weasel can suck eggs and leaving only an empty, meaningless shell. And I'll give you a few examples, like you have Hungarian notation, like this is a double amount. Who cares about the data type? You have an IDE, you can hover with your mouse to see the data type. It doesn't infer business meaning. The same for philosophers. You have meta customer or customer layer. What does it mean? What's meta? You need an extra explanation for that word actually in itself. You have the importance and the simplicity things like, oh, this is a basic customer, but this is an advanced customer. Maybe for you. I'm smarter, so it's not. So these things don't really convey meaning. And we don't stop at the simple technical patterns. You have gang of 4 patterns, POEA, domain-driven design. Like you have your customer DTO, your customer repository. That doesn't really add any business meaning to your code. It just describes the technical structure of the thing underneath. I don't want to see that in my business code. And we don't stop there. There's like, I'm not going through all of these. You can see the slides later, but there's so many weasel words, we're not even aware that we're using them every day. But whenever you think, oh, this term doesn't come from the language of the business people, this is a technical thing that I'm describing, don't put it in your business code. So getting rid of weasel words, amazing. Now we have a source quencher, not a container. We have a multi-but. Oh, wait. Something went wrong here. The multi-but supporter is now a that's wrong. What happened here? We had a misnomer because a supporter is a pattern, but it's also a word from the domain. So actually this would have been a multi-but supporter, maybe, but what to do about this? Well, if we talk to business people, this is a language we actually get. They talk like that. They have a people and a picture and a TV and a sofa. We need those terms in our language. So let's start with an experiment. I brought you code, very complex business code. This is my customer repository, and it gets customers by year of birth with a datetime, year of birth. Could we optimize anything? And don't say C#. That's not the problem. And yeah, name of the function. How could you rename this? What would you? Okay, so he said get customer by. So customer repository, get customer by year of birth. Great. That's how we talk, right? I go into the room and say, hey, customer repository, get customer by year of birth. Can we optimize more? Yeah, or we could remove repository, 1 second. So customers get by year of birth. Great. Customer by year of birth is even better. Ooh, nice. Customer born in, almost as if I prepared this. There's a trick by Eric Evans, a pattern or a methodology, language. It's just a point, right? It's called model out loud. If you read your code loud and it seems awkward, change your code. So, of course we say customer repository get by year of birth and we're done. That's natural language to a programmer, but nobody would ever say that in real life. Get by year of birth. What kind of language is that? Born in is what we say. Customers born in, and you see I did more. I changed the data type from datetime to year. Why? Yeah, it's primitive obsession. We have a primitive data type called datetime, and it has minutes and days and milliseconds. My year of birth doesn't have anything to do with January the 1st or January the 2nd. It's still the same year of birth. So giving a date time, I have two date times that are non-equal, but they will give me the same list of customers. That's kind of irritating. The domain model is not really expressive of what we want. We're just using a primitive data type. So I have this rule in my domain code, not in the technical one, but in the domain code, there are no primitive data types allowed. There is no int in your domain, unless math is your domain maybe, but there is no int. You have an age, a distance, you have size, a value, but there's no int. You don't have a string. A name can never be null or empty. A name has to have letters. So there is rules for the simplest types, even if it's just a very small rule. And you build these types by just having a primitive data type hidden behind another type. But it has meaning now. I say customers born in year, and this is type safe. I can't take 5 meters and put them into the year 1968 because it's a different type. An int and an int can be, oh my god, switched. This can't happen here. So now we have, yes please? The what works? Oh yeah, the return type? Very keen eye, that man. Okay, so that's the thing I do. IEnumerable, for me, is not a primitive data type. I use this because it's masked on the outside. You see this in the usage. I say all customers turning 50 and then I return something. You don't see that type. But you're right, if it adds more meaning to your code, find your own type that has meaning as like a customer list. So what you get is instead of repo, new repo, C is repo, get by year of birth, new datetime, that number, you can now say all customers born in the year of 1968. Ooh, that sounds like English. I think even Kevin Henney would say yes as a writer. That's beautiful language. So, but how do you do this? Year of 1968. A value type is super simple. It's really one of the most simple things to build. You just make an immutable data type in C# that's a struct with a private constructor, and then you say, look, internally the year is just an int, but I don't want to accept ints because int in my domain is a primitive. So, and I want to make the constructor private so that nobody can say new year, because new year is one day in the year, and not every year. So you have a static method that returns a year, and the method name is off, and you enter the int, and it returns then the constructor where you can actually see is the year in the valid range. In our domain it's between 1900 and 2200, otherwise domain exception. Very simple to build. You can even override to string and say year of and then the year for your test frameworks to get meaningful output. And the next beautiful thing is, because of the exception, you now know null is not possible. You can't have a null value. Every method that accepts a year doesn't have to check if the year is valid. If you get a domain value type, you know it's valid. It has to be. It can't be any other way. So you can forget all your null checks and all your other validations inside of your business code. Once you get the objects, you know they work. Legal domain state only. That's cool. So, that's how our business code looks. Who's German in the audience or who can read German? Cool. So, good for you. Read that and check if it has errors. To anyone else, you don't need to understand what's written there. That's just some boring German holiday calculation system, but it's written in pure language. You can see scenario with coworker and birth date and entry, and that's a business language. You see some enums and some classes and some methods, but it's only business language. And now you see I'm using German because my domain is a German one. I use my native domain language as my business language in code. The technical part, the should be down there, that's a test framework. And because I do that, now I can see if I have English and German mixed in my methods, I know I'm mixing abstraction layers. I have fetch data from database, berechne mir Übertrag, store data in database. Oh my god. There are two different languages because I'm using business and technical terms. That's a benefit you only get when you work in a non-English domain, of course. But anywho, if you do that, that's a great benefit. So, now we have a ubiquitous language. We modeled together with business people, we spoke out loud, we figured out how the language should look like, and we brought the domain concept into code. But we have to be careful that there's only one ubiquitous language per bounded context. That's a question. Sure. Oh, good question. So isn't that an anti-pattern? Because if you write everything in your domain language, people you employ have to learn your language. Your domain language and your natural language, right? So yeah, that's a trade-off. Not an anti-pattern, but a trade-off. Very good question, thank you. If you do this, if you say, we speak German and our domain is German, let's build everything in German, that means the complexities and the intricacies of the actual domain language is easy to understand for Germans. So if we hire expert programmers who understand the business very well, they can talk to customers natively. That's a benefit. And the cost is, we can't hire any of you smart people who don't speak German, to do the same work for us. If we say have 50% of English programmers and we really want to use them in the core domain, then at some point we switch to English, of course. We build the system in English instead of German. Then we lose one benefit, but we gain another. And this trade-off has no clear, oh, this is a cookie-cutter rule, do this or don't do this. It totally depends on the flux and the change and the complexity and if your customers are able to speak English at all or not. So it's a big trade-off. We made it consciously because we have only German-speaking customers. They don't speak English at all. And we only have German-speaking programmers. So yeah, we kind of went that way. But of course, could be a problem for international companies. Good to have in mind. Yes, please. Yeah. Yes. Yeah, that's what I said. If you totally. Yeah. Get you. So what I get from this, the language you use to speak to your customers should be the language that you put in code. Exactly. In our case, it's German, so German. If it's Dutch, put Dutch in. If it's English, put English in. But it's a more complicated trade-off, as he just figured out. So continue. One ubiquitous language per bounded context. So we have all these contexts, we figured them out, and now you have something like the word customer. And you have a customer in shopping, you have a customer in the warehouse, you have a customer that you deliver stuff to, and the customer has to pay. So you build one nice class with all the behavior and put it in all the bounded contexts, right? Oh no. Why not? Well, simple. If my class customer is in shopping and I want to change it, I want to add behavior or change behavior, payment has to be tested because we're using the same model, so we're basically one bounded context. That's kind of what we didn't want, right? There's one language per context. We can use the same word, we can both say customer, but it will mean something different. For delivery, a customer is just an address that you deliver stuff to. There's no behavior involved at all. Maybe there's a method that I could say revoke. I don't want that anymore. You're still sending it, but I don't want it, so ship it elsewhere. But that's it. For shopping, it's only like I'm interested in these things and other people have been interested in these things, so I get recommendations. Warehouse doesn't really have anything to do with the customer. There are orders coming in and you need to pack the orders, but otherwise there's no customer. And then payment, people have to pay money or they owe or you owe them money, but it's creditor and debitor, not really customer. And if you change that language, if you make two classes out of one, you can do that if you have that context and the class is fixed in your own bounded context and not share the meaning between those contexts. So your mental model becomes your code model and the other way around. If you learn something into deeper insight, if you go deeper in your domain, you reflect it in code and the other way around. And now you've just discovered domain-driven design. You're welcome. So, domain-driven design is to tackle complexity in the heart of software. It's a book by Eric Evans in 2003. And what we actually discovered was we have a team of business developers and of programmers. They work together to solve a common problem in a certain language per context. And in between those contexts, they have to find the language that people use when they talk together, also as a technical layer. But domain-driven design is not about the building blocks. Very important. Whoever starts reading about DDD in the blue book, the first 7 chapters is just building blocks, technical patterns. These patterns help you if you live 2003, you do Java and have an SQL database. These patterns are very good to be more expressive in code. Nowadays we have functional reactive programming, event streams and other things, so use whatever patterns are good for you to be better at expressing language in code. That was what it was all about in the technical part. And in the architectural part, messaging, CQRS, microservices, all those great things. Nowadays it's serverless, even added to the list. They are all cool patterns to build better technical infrastructure. And if they help you to slice your bounded context in a technical way, use them. If you find better patterns, change it. If you hear those things being, oh, this is DDD, no, it's not. Domain-driven design, in my view, is this is a DDD tornado. You discover what is by talking to people, understanding the problem and modeling. Then you dream what can be by designing solutions. And then you design what shall be by actually building a model that can be implemented in code. But you don't stop there. That's not one step and then you're finished. You do all these steps all the time. You always discover more and you go deeper. When you start a project, it's the moment where you know the least about the project. So in the beginning you know nothing, and then you shall design the whole thing. That's impossible. Start with a big picture, dig deeper, and go into more and more details afterwards. So how do we model business software? Well, it's simple. It's 3 easy steps. And whenever someone sells you 3 easy steps, what do you say? Right, sure, yeah. You're right, man. You know what you're talking about. So it's an abstract 3 easy steps, so I'm right. What we do is we extract the right model to be able to help. The thing in brackets is really important. Then we put the model into semantic code that differs meaning, business meaning. And then we secure that code from corruption. If you do these 3 steps, no matter how you do them, but if you do these 3 steps, you will build good, meaningful business solutions in software. But even I'm a German, this is a dance, not a march. You don't go, yeah, model, extracting, semantic code, secured. Software's done. As I said before, it's an iteration process, and whenever something comes up, you go into deeper insight, you learn more, you dig deeper, you repeat these steps all the time. Software is nothing that is robust, it's just there and working. It's something you have to maintain. It's like a garden. You have to keep it clean all the time. It just takes one junior programmer from Belgium that comes in and says, oh, Marco, great code, and all is ruined. So we need to be careful about that. Those Belgians, man. So, step 1, extracting the right model to be able to help. I invited 2 domain experts. I didn't hear that. I invited 2 domain experts and they bring us their domain. Please take a few seconds to dig into this. So, this sounds like gibberish, right? Actually, that's every domain language. When business people come to me and they talk to me, sometimes they use words I even understand. It sounds German or English, but then I just have an idea, an assumption of what those words mean. And it's dangerous because I think, oh, you're saying these words. They have meaning. To me, a different one than to you. So actually, that's the best domain language you can get, somewhere you don't have pre-assumptions. So what do we do? How do we get to a model from here? What would you ask? What would be the first question? Oh yeah, please give me the translation table. Please explain to me what all these words mean, right? Well, I would say no. Because if they explain these words, they will use their own language to explain these words, and then again you have an assumption of what they might mean or not. And then you get a long list of things, what everything could mean or not, and it will tire you very much before you understand everything. What would be way better to start is look at those terms. Someone says, oh, it's important that the fleep is rubbed because the fleep has all of the fleep juice. Something is important and there's a reason for that. If you take that and ask, okay, what if this doesn't happen? What happens to the process then? All of a sudden you get a story. And stories is where people excel, where they give you meaning. If I just give you a list of words and what they mean, you'll get definitions, technical ones. But if I tell you, oh yeah, no, this is important, cool. The reason, because the fleep has all of the fleep juice, is not a real reason. It's a fake reason. Why is this a because? What if you take orange juice instead? And asking those stupid questions is really important. Learn to ask stupid questions. If I ask, what would orange juice do? Sometimes a business person is like, what? That makes no sense. Great, now I learned something. Or they would be like, yeah, but that's way more expensive. Ah, cool. So there's a price constraint, but it would actually work. So then I can get into deeper, like, what is this fleep juice actually doing? Why do we need this? And go further and further in asking stupid questions to actually learn about the business process. Also important, the time frame. People say first take this, then repurpose, then take. Whenever someone tells you this order, then this, ask, what happens if I switch these around? Even if it sounds stupid, you don't know. In some business processes, this is, oh my god, no. In others, that's a logical fella. It couldn't work. You can't first repurpose something, then create it. That's impossible. I didn't know that. Great, thank you very much. But sometimes you ask what happens if you switch it around, and you get new insights. Like, oh yeah, we tried this. Then stuff burns in the end. But so, cool. So that way we actually learn about the whole business. And then you have these nice qualifying words, bunch, later, several, regular, old. You already know what I want to do. I want to ask, what would a regular new one do? Or an irregular old one? Do they mean regular old as a standard term, like the default thing? Or is it an actual expression, regular and old? I don't know. How much is a bunch? 2, 200, 20,000? Well, I have no experience in your domain. So all those things need to be specified. And my metric, my general heuristic there is, when someone tells you something is binary, it's black or white, 1 or 0, I'll always ask, is there a spectrum in between? Are there gray areas of truth? If someone tells you, oh, it's a continuum, cool. Is it one-dimensional or two-dimensional? Black and white, but are there colors? Always go one dimension higher and ask what would happen if you switch these things around. Then you get good stories from business people that show you their emotional reaction to your story. But we didn't ask what the actual problem is. So digging deep is great. You get stories, you understand the domain, but why are they here? How can we help? Do they want to open a new market? Do they have software already that's just buggy, and do they need better developers? Or do they try to explore a new domain that they themselves have no clue about, and we can experiment together? We don't know. And the thing is, when we develop software, the learning process is a bottleneck. Working software is a side effect. That's a nice quote by Alberto Brandolini. He invented event storming as a modeling method. So working software is just what you produce whenever you understood something, and whatever you deliver is the understanding at the point in time that you build that software. But by the time it reaches a customer, you already learned more. So you keep on learning about the problem domain, and this learning is what actually makes you slower, or what actually is slow. You can learn to type faster, you can use better languages or better architecture, you can build your code double the speed than the competition. But building more code faster only makes your maintainable code larger, faster. It doesn't start to make you understand the problem better. So we need to bring people together and talk, right? Is this a great scenario? Remember the 3 core pillars: communication, empathy, and the ability to learn. So this is a great communication situation. Everybody's in the room, everybody has a mic, we can all talk. But the person next to me is the person I can whisper with. I have a different communication with that person than with that person or the person behind that. I can say, what an idiot. He won't hear it. The person behind that is opaque. I don't see that person. I can't model with that person. And the person sitting next, opposing me, that's an empathic problem. Psychologically, we're opposing each other, so we're enemies. These are my friends. You're my enemy. That effect is there. It's small, but it's there. So, and the next thing is people speak. And spoken words vanish. When I say something, 5 minutes later you say, yeah, but you said... And I'm like, no, I said this. No, you said... No, that's not what I meant. I meant this. So what you want to do is, you want to make words stick. That's where event storming comes in. You have sticky notes. Great. So in event storming, it's a mixture of events, domain events, meaning things that happened in the past, and storming from brainstorming. Event storming is a modeling method where you take the right people, give them a limited amount of time and infinite modeling space. I prefer IKEA paper rolls, and a wall like this, actually, amazing. Next time we do an event storming workshop down here. And in a few hours you can model a complex business domain and get deep insight into the actual problem space compared to what would otherwise take weeks or months of analyzing and sequential requirements engineering. So, but how do you do this? How do you take a few sticky notes and a few creative people and get to the biggest and best model you can build? Well, the key is in the right people. Who are the right people for modeling? Business people, great. But is it a certain role? Do you need a CTO or a CFO or the domain expert or the user or the programmer or the tester? Like all of them and none of them. The point is, that's not the point. You're asking the wrong question. The right people are very simple, those with questions and those with answers. Usually the people who want to build software have questions. They want to understand your problem. And those people who have a business have answers. But also, the old programmer from the old software has answers, because that person has been there for 10 years and is already deep ingrained into the domain. Sometimes even more knowledgeable than the actual domain experts at the customer. Because if you have more than one customer, you get more perspectives. But also users and customers of the customers, like whoever works. There's a psychological limit, a communication limit. You can't have like 30,000 people in a room. You can't even have 100 people in a room. There's a natural barrier somewhere between 10 to 15 people. In really good groups you can work with 20, but at some point communication gets so complicated. So find a small group of people that has a valuable mix of answers and questions, and then start modeling by writing down what can happen in your domain in past tense on a sticky note and put it on the wall from left to right. And then people start writing down stuff. And then other people are writing down stuff and I'm like, no, that's wrong, no, that's wrong. This should be the way. No, this should be the way. And then everybody's in a chaotic flux. And that chaos is wanted. You want chaotic modeling because it's very time effective. You will never get the perfect model right anyway in the first take. But usually if everybody's listening to the one person speaking, like here for example, then you have only very limited information that you can spread in the group. But if 3 people are focusing on that part of the model, 5 people are focusing here, but at a point someone is like, okay, I think this works, but that's wrong. Like everybody can align themselves with the part of the problem that they think they can help the most. And then you will find something like this after a while. You find people saying, oh yeah, if I send this command and there's a business decision here and then this happened and then, oh no, this thing, we have to mark this, that's problematic, we need to find a solution for that, that should never happen. And then you find groups, like this is an actual modeling at a customer of mine, you find groups that hurdle around certain parts of the problem and you realize this could be my initial bounded context. This is kind of like the warehouse team and these are the payment teams and back there is like another team, and you realize, oh yeah, there are small groups of things happening together and then there are events. If order has been sent, then the warehouse team starts doing stuff. Not before, not after, just as a reaction to that event. Great. So from this big model, and event storming is more than just events, you also add the screens, you see the information you get, you model, okay, whose intention is this, who wants to do this, who's the actor here. You get like the whole time flow and the reaction of things in your whole business. Still not technology, that's just language. I want to order this. Okay, if we have it in stock, it has been ordered. Otherwise, no alternative has been provided or something like that. If you have that, you need to put that into a semantic model. So how do we use sticky notes and language that we just deferred from a talk with business people that looks like this into a semantic model in code? Well, there are a few architectures that work very well with that. One is CQRS and event sourcing. Who has heard of CQRS and event sourcing? No wonder Red built stuff, right? It's kind of Greg Young was very involved in this conference and he invented this pattern. So you have a command and query responsibility segregation. On the command side, the user sees information from your system and says, oh, I have an intention. I want to order that Ferrari. So that command goes into the domain part, in the business part of your software. And there are the business rules saying, oh, if we have Ferrari in stock, Ferrari has been ordered. Otherwise, find an alternative solution to make that customer happy. So Ferrari has been ordered, updates the screen. So the next person who wants to order that Ferrari just sees, damn, last Ferrari just gone. Sorry. So you have your commands and your events and your queries and your rules already on sticky notes in colored form, and they represent command objects and event objects in your code, and also the entities or the structures of the problem-solving business classes, like the rules, the functions that are there. So an event like shopping cart has been ordered would just be a DTO, a data transfer object, or a class named shopping cart has been ordered, and the properties would be ID of the shopping cart, ID of the customer, list of products that has been ordered, and the date. That's it. You can use that to fill your screens by projecting, oh, whenever this happened, change this stuff in database or update this stuff on screen. And the same goes for the domain. Your internal state of we have 3 cars goes down by 1 whenever this happened. That's very simple. So finding a simple architecture that is aligned with your business needs instead of one that is opposing it, it's a great thing to do, and secrets event sourcing help a lot there. Yes, please. Per bounded context. So the question was, is this the idea to build software for the whole company like this, or just per domain? Which is a funny question, depending on how many domains you solve. But a per bounded context is the real answer. So if you have like Beamazon, you have shopping and payment and stuff like that, the shopping team can decide to do secrets and event sourcing, which is a great architecture for many problems, but not for all. And it's costly, because designing it like this means you need to actually model your language pretty thoroughly, and that takes time. We already figured payment is a generic problem space, and even if we build payment ourselves, I don't want to do event storming and find all the nitty-gritty details. I just want to provide a table and data and then done. So every bounded context can choose their own architecture, but if you have pairwise context, they can also reuse the architecture, of course, but it's a decision you make per bounded context. So then, step 3, we want to secure this code from corruption. So we found our amazing domain model, and we put this domain model in the middle, and the domain model, because it's the actual value that we provide, should be the most secure thing. It should not have dependencies on other things. In the classical layered architecture, where you have like UI layer, facade, domain layer, Hibernate or database or whatever, it's in the middle. So other things are depending on it, and it's depending on other things. That means, for technical reasons, your domain code could change. That's very bad. I don't want to retest my domain just because I switched Hibernate with another ORM. That would be really bad. I want my domain code to be pure. Purely functional would be the really best. So if I have pure functions that do stuff and that are semantic, they are correct all the time, no matter what technology is underneath. So what I do is I use ports and adapters. This is called the hexagonal architecture, and I hate that name because it has nothing to do with 6 sides or a hexagon. It just looked cool in the first book, but it's actually ports and adapters. So you have your anti-corruption layer up there with some internal messaging, you have your REST interface over there, and there's an infrastructure part, software part, that translates between business and technical. That is the only place in my whole code where I actually mix English and German. Because there's an object coming from a REST interface, and it has the name Bestelle Shopping Cart, which is an English word. Well, no, you know what I mean. So there's a technical thing that has a German word inside, and it's calling the domain object, which is purely German, purely domain language. And then whatever comes out of there, I'm storing in the database again. But in this specific thin layer, in this port and adapter, I want that. This is where I mix both. So the port and adapter pattern says whatever comes from the outside world, I know what object to load, I know what method to call, and then the domain is pure, it's just doing stuff. That means in my domain object there's no constructor calling the database, of course. That's bad code anyway. There's only functions that you give parameters in domain language, and there shouldn't be any primitive data types in there. And because you structured your code like this, it's super easy to have the orthogonal concepts, architecture and domain, never really depending on each other. So, but why zum Geier would you take all this effort, do all the modeling, build all the... I mean, we built software before, right? And it also works. Why do we put so much work in this? Because software becomes what developers understand, not what business people mean. But what business people mean is actually the reason why we build software. Because software development is not about software, it's about helping business excel at what they do. So we want code in harmony with our business. We want deep internal trust in our team. I don't want to have business people fighting me or holding back information, or my PO being kind of like psychologically manipulative. I want people to trust me so we can work together for a common goal. And I want to be safe from external influence. If we as a team work on something, business people, technical people alike, I want us to be safe from whoever's in the next department because they change architecture, we have to adapt. That sucks. I don't want to do that. I want to work on the business problem that I'm solving at the moment, and I want to be feeling safe about that. So to make that happen, we need to move away from reward and punishment. Command and control is not working. It is in the obvious domain parts. So when you have, like in the Cynefin framework, when you have an obvious complexity, you can delegate. You can do command and control. That's super fine. But in all of the other complexities, that's not the solution for you. You want to strive for engagement. You want to get people engaged in what they do. So they need autonomy in what they do and when they do it and how they do it. Not everybody has the same need for autonomy. Some people really want to have freedom, pure freedom. Other people say, yeah, I don't mind the language. You give me the technology, but I want to solve this problem in my way. So autonomy means different things to different people. But that's what autonomy is all about. Choosing what to do, when to do, and how to do it. And we strive for mastery. So in DDD, if you do like these kinds of modeling and architecture, you can master in technical things. You can be the best React developer there is. You can become the best F# advocate or whatever. You can be the best architect for CQRS and infrastructure. You can also become a master in the business rules. So I'm not that good with coding, but I really understand how hospitals work internally, and I'm really good at communicating with hospital people. That's also mastery in my bounded context. And you can even go to a meta level and become a master of facilitation. I don't really understand the domain, and I'm very bad at programming. I'm still a very valuable part of that team because I facilitate everybody together modeling and understanding, and I keep people emotionally safe. It's also a super important role. No matter what your strengths are, you can bring them in and master and excel at them. And purpose, that's kind of like what DDD is all about. You have an actual domain that you solve a problem for, so purpose is a total given. But if you go for these patterns, there are challenges, and that's always important to know. You want to take a photo? Sure, take a photo. So there are also challenges. Nothing is ever for free. If you have hierarchies in your company and you introduce domain-driven design from the bottom up, the developers say, let's do this, so great to actually care about the business, yay. Then you have middle management, and middle management saying, oh wow, that would mean I don't have a power position anymore. I'm not giving up my power position, I worked hard to be here. So you have to fight people, and if you have to fight people, emotional safety is gone, and the whole thing doesn't work anymore. It takes way longer to take people with you, to guarantee job safety but not role safety, to take them along on the ride. You need a good facilitator, maybe a scrum master. I'm not giving recipes here, just ideas, but it's hard. You have to think about that problem. Other way, when you're like, when DDD comes from top to bottom, the CTO has heard on a conference from this amazing Marco Heimeshoff, there's this DDD, we do this now. You have developers that are developing SQL for 20 years and they're successful with it. They will not change now. They will not start doing event storming and classes and this and that. They know how to build software, and you have to take them on the journey. And this takes time. A huge company isn't converted in a year or in a decade. Sometimes you have to say, look, this part of my domain is a new bounded context, and they can do whatever they want. The rest stays the way they are, and you have an anti-corruption layer in between. And that's good. So don't expect everyone to share your joy of domain-driven design and emotional safety and modeling just because you know it's the right way to do, which I'm imposing. So another thing we developers especially often have a problem is perfectionism. You will get very frustrated if you start DDD only when you are perfect at it, when you really understand it. I'm not doing CQRS architecture before I really get it. But if you do that, you will never start doing it. So I would advise starting with all these things and start with the low-hanging fruits. If you want to start having better communication with developers and business people, start with value types. Just say no primitives anymore. Let's figure out, what is this thing? What is this int? Oh, this int is an age. Great, now I have an age type. It's a low-hanging fruit. You can start immediately, get benefit, and it's not a lot of effort to do it. But once your code gets better, your tests get better. Once your tests get better, your conversation with business people gets better. But then you hit a block, and then you start with event storming and have better conversations. And then the event streaming and storming and sourcing part comes afterwards. So go with whatever works easily in your context. Don't try to make everything at once perfect. That would just frustrate. So, and there's a list of other constraints that I'm not going into now, but be aware. I know this is great. I really love this, but there's hard work involved. And what helps is reading. I read a lot of books. Actually, I don't read a lot of books compared to a lot of other people, but I read these books, and you can see there's only 3 books in the DDD area that I've read that I think are really great, and most of the other books are not even about software. Because again, software development is not about software. It's about psychology and the transfer of learning and system thinking. Those are things that are really important, and of course you need to be a master in your tools. You need to practice C#, Java, whatever you do. If you can't do that, you can't build software. But that's just a means to an end. And the really hard problems are in communications, psychology, and system structure. So, you shape the future of humankind when building software, because software is everywhere, ingrained in everything nowadays, getting more and more each day. Shape it good, and change code and culture and the agile and architecture of your businesses. If you want to learn more about these topics, there are a few conferences throughout Europe and the world. There's Kandinsky in Berlin in October, DDD Europe in January in Amsterdam, and there are meetup.com. You can find DDD meetups everywhere, and also the DDD Exchange in London. And now, goodbye. Live meaningful lives.